1.1. Enterprise Integration Patterns and Service-Oriented Architecture. The last decade or so has seen a renaissance of application integration. Gone are the days of proprietary messaging stacks and closed APIs. Open platforms, protocols, and services dominate the landscape. Nothing is more evidence of this than the API explosion of recent years as companies, organizations, and governments race to expose their data. REST, JSON, and lightweight message brokers lead the charge but, as always, don't allow you to throw out what's already in place, or more importantly, what already works. These nimble new technologies also don't solve what is ultimately the bigger problem: how these services are composed into distributed applications. Until Hopp and Wolf's seminal publication of Enterprise Integration Patterns, Addison Wesley, November 2003, there was little in the way of prescribed solutions to solve these, and many other, integration challenges. When developers of integration applications finally had a catalog of patterns, they were still left with little in the way of implementations. This is how Mule and many other open source and commercial integration frameworks received their cue. The integration developer was now freed from having to implement the patterns and could once again focus on the solutions. A parallel phenomenon to the publishing of enterprise integration patterns was the emergence of service-oriented architecture. Service-oriented architecture, or SO, is a software architecture style that acknowledges the need for integration upfront by providing well-defined, programmatic means for interacting with an application. Initially embodied by the heavyweight SOAP specification and more recently refined by the widespread adoption of REST and JSON, SO has become pervasive in the modern software development landscape. Guerrilla SO. Early SO adoption was usually done with heavyweight integration technologies like SOAP, verbose XML, and the complicated infrastructures and tooling that come along with these technologies. Compounding this complexity was an unfortunately common waterfall approach to integration development, in which existing infrastructures were converted to SO over a long period of time. The fate of many such projects is unfortunately obvious to anyone reading this book. Guerrilla SO, a concept introduced by Jim Weber, www.infoc.com weblink, is the idea that service-oriented architecture can be introduced in a lean, incremental, and agile manner. We'll see in this book how Mule, along with lightweight messaging patterns, alleviates the pain of introducing SO to your applications. We'll cover Guerrilla SO, as well as other architectural approaches, in Chapter 7. There is a natural, but unfortunate, tendency to integrate applications informally. This often leads to spaghetti integration, as illustrated by Figure 1.1. Applications in such implementations are connected directly to each other in a point-to-point manner. On a small scale this might be okay. Pain quickly becomes apparent, however, as the number of integration points grows. The application becomes mission-critical, and your remote systems begin to change. Figure 1.1. Point-to-point, or spaghetti, integration. A pattern described in Enterprise Integration Patterns that solves this problem received attention from the industry and community. The message bus, commonly called an Enterprise Service Bus, or ESB, when implemented. The ESB, depicted in Figure 1.2, provides a solution to the problem of point-to-point integration. An ESB architecture prescribes placing a dedicated integration application, called a bus, in between all of your integration points. Your previous point-to-point integrations now all talk to the bus, which decouples them from the remote applications. Figure 1.2. Application integration with an ESB. This decoupling is achieved by protocol adaptation and a canonical data format. Protocol adaptation means the bus can communicate over different transport protocols, like HTTP or FTP. A canonical data format is a common format all messages are transformed to, usually a common Java domain model or XML schema. This allows you to centralize concerns like security, auditing, and routing onto the ESB framework. It also means your client applications are insulated from the volatility typically present in integrating with remote applications. This provides the flexibility to do things such as swap out one vendor API for another without having to modify every downstream application. Although Mule is often billed as an ESB, it's important to note that an ESB is an architecture and not a product. We'll discuss using Mule as an ESB, as well as in many other ways, in Chapter 7.